Thank you. I mean, that's far too kind. I was thinking also that not everybody is interested in writing, but everybody reads articles. So actually it's quite useful for those people also who like to read and maybe read a bit more critically. I mean, when you're an editor, you get hang-ups with, you write your principles and so on. So what I'm going to do now, just in 25 minutes, I'm going to do this. I'm going to say how to write an article. But I think that what I will try to keep in mind is that I want to tell you how you can write an article in such a way that it's guaranteed to be accepted and published. Okay? So, for those who want to learn that, stay. The other ones can go and have an early lunch. I will not take any offense. I will say just a little bit about rubrics that you can write within, so the types of articles, and then a bit about the structure of articles, the writing itself, the technicality of the writing, just very briefly, what's important, and what's worth writing about, just how do we think before we embark on the project, how do we present results, and then I'm going to do all the statistics in about 5 minutes. Okay, good plan? Well, you don't actually have any choice, so this is the plan. Right, this is the journal. So we have the following rubrics, mostly. So everybody knows what an original article is. This is a research article. It should be an original presentation of some material that you have counted or measured or whatever, and you come to a conclusion. Everybody knows. I'm going to return to that. Review articles. For me, a review article is an article which has a critical gaze at an important question and looks at what has been written in the literature and criticize it. You should criticize it and you should discuss. If there are different opinions, you should look at both opinions and you should look at the evidence between, and you should try and come up with a conclusion. Why is there a discrepancy in opinion? Okay? That's a review article. Then we have something called a pictorial essay. And this is something that most of you can write. Okay? So if you need an article on your CV, you think, aha, pictorial essay. What is a pictorial essay? It is a piece of teaching. Okay? Who is it for? What you should think is that I'm going to write this as if I am teaching my senior resident, my fellow. That person who has done 3, 4, 5 years of radiology and who now has chosen to subspecialize in pediatric radiology. That's the level it should be at. Okay. And you all know how to do that. You need good pictures. You need a representation of the possibilities. If you are writing about tumors, you need examples of all the different tumors. But of course, you wouldn't write a paper on tumors. That's going to be far too general. You would write something about how to image bilateral Wilms tumor. You see, that's the sort of level you would gauge yourself in towards. The stuff that you would teach your senior residents, not the junior ones. That's a pictorial essay. Okay, clear? Case reports, you don't need to bother writing case reports because we don't publish them anyway, so just forget it. It's easy for me because I just reject them once they come in. So, don't even bother. Send them to one of the online case report journals, like, I've forgotten the names already. Letters to the editor. If you have something that you think might be nice to put in a case report, but you've heard my lecture and you think, no, I'm not going to do that, then what you can do instead is that you can send a letter to the editor. And you can say, dear editor, we did so and so. We came across this very interesting case which shows some very, very specific findings that we don't think have been published yet. And here is a picture of that. Yours sincerely. Okay? So rather than putting in a case report, letter to the editor. Because that has something to do with that not changing the impact factor of the journal. You see, if we publish a lot of case reports, our impact factor goes down. If we put the same good messages and good images in the letter to the editor, it doesn't influence our standing in the impact factor. That's the reason we are doing this. Okay. So, 2 tips. If you are not going for the original, go for the Pictorial Essay or the letter to the editor. Much easier. Okay. Now, so this is going quite fast. Now I'm done with the first bit, structure. Okay, let me talk about the original article first. Some people are going to write original articles, and there are people in this audience who have published with us original articles. Excellent. So the best thing to do, because I don't have time to go through everything, is that you can just Google STARD, S-T-A-R-D. So, and that gives you the list that you can see on the right-hand side here. What's this say? I can't actually see from here. But if I speak up, then I can stand here and read with you. So, for example, it tells you this is the title, introduction, method, results, discussion, da 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 da. And step by step, you say, what is your question? How did you recruit patients? How did you collect your data? What's your reference standard? Were you masked when you looked at it? Who looked at it? How did you do your statistics? Everything, checklist. Makes it very easy. I don't need to say anything else. STARD, there are several of these. STARD is one, you can start that. Okay, basically what we want something that's simple. The editor is a very simple person. The editor doesn't have much time. Okay, bad combination. Really bad combination. You need to write really simply, otherwise the editor just goes, and maybe loses the plot completely. You have to be very simple, very short. The shorter the better. Yeah? I don't want you to churn out page after page after page. I just, after 2 paragraphs, I'm out there. I'm thinking about something completely different. You know what I'm having for dinner? It has to be very short and very simple. Think about that. What's the problem? What do you want to do? How do you prove that your results are credible? What are your results? And what does it mean? That's it. I don't want to know anything else. And they go in different bits. Something goes in introduction, problem target. Why bother? What's the point? Why do you want me to read it? Why? Well, you have to point out to me that there is a problem, there is a controversy, there is something that we are not quite clear about, something unknown, something new. Okay, I'm interested here. And then you have to say, what exactly is the question you want to answer? If I don't have a question or a hypothesis, when I read your statistics and your results, I don't know where you want to go. Right? You have to ask, there has to be a question before you give an answer. Right? So this is the fundamental. If this is in place, then I'm switched on and I will actually read the rest of your paper. If not, I may just finish here. The only long bit is the materials and method section, because that has to be absolutely complete and detailed. And what you need to keep in mind when you write this is you have to write it in a way that anybody who reads your article can do exactly the same and come to the same results. Unless it is that level of detail, the method section is not good enough. What's next? Results. The results need to tell a story, and they need to make inference. What does it mean to infer? It's not an English test. To infer in science means you take what you have found. You have studied a sample. You can't study the world population, okay? You have to restrict yourself. You can't study the whole of Greece. You have to restrict not even your own hospital. No, you have to select a small, manageable number. How do you know that what you have found in a handful of patients is also valid for every patient in the whole wide world? That is inference. That means to infer. And that is the point where you need statistics. That's the point of statistics. That's the whole point and the only point. And some people think the point of statistics is that they just belong in it just has to be there. You know, some t-tests and p-values is fine. No, it's not good enough. It has to be a specific answer to your hypothesis. Is this valid in general, not just for the 5 or 10 children that you have studied? And then you have to be able to present your result in one short sentence. This is what we found. These are the limitations of our study. For example, we were only one observer, or there was some problem with imaging in some cases, and we were not masked to the result, these things. Okay, and then is this new? Is it something unexpected? No, does it answer the question? Why not? That's the discussion. And then you have to say, what are the implications of what you found? That's basically it. This is the structure of an original article. Just follow this. The most important is in the beginning. You have to tell the editor why this is important. The introduction, do not write an introduction more than 1 page. Maybe 1.5. Okay? Short. Little time. Done. Structure done. Writing. How do we write? Okay. 3 keywords for writing. It has to be narrative, so you have to tell a story, because it's much easier for the reader and for the editor and the reviewers to follow. Okay? Tell a story. Be simple. Very simple. Short sentences. Simple words, and precise. If a word can have many meanings, it's the wrong word. You have to use the word that is precise. That means precisely what you mean to say. And I will give some examples of all 3. So I will first give you an example of a narrative. I have to move, don't I? Because I can't really... Oh, I can actually see, because I do have my glasses on. So now... Okay, so... Actually, I can... Yeah, are we good? Yeah, I can see, you can hear. Yeah, all good. Okay, so this is a narrative article. Here we go. I think we're all fine. Thanks. Okay, so this is the article. I've just invented this for the occasion. It is difficult to predict the effect of chemotherapy because tumors do not necessarily shrink. We hypothesize that PET-CT after 2 weeks can predict ... Okay. That's the introduction. So you have a background and you have a hypothesis. Short and sweet and interesting and important. Materials. We included, we imaged, 1 consultant measured, we compared, the outcome measure was, this is how we did the stats, etc., etc. There needs to be a lot more juice and meat inside the materials and methods, because that's the only bit that's allowed to be long and complete and detailed. Results. In the group who had a desired outcome, our measure was X, while in the group with adverse, it was Y, the difference was Z, and the p-value is so. The p-value is the inference. Do you remember? Inference. If the p is not low, that means that the results could have been due to just chance. Because chance happens all the time, and it might just be that you were lucky. But if your p-value is low, it means there's a very low risk that this just came about by pure chance. That's what the p-value tells you. There shouldn't be many p-values. There should be 1 p-value for that result which relates to your question, to the hypothesis. That's the only p-value you need. Discussion. We found a significant effect. Significant, yes, we call it significant when the p-value is low. There's no magic about 0.05 or anything like this, okay? We found a significant effect. 1 limitation was that there was only 1 observer. Smith and co-workers made different observations in disease X, but we think that ... and we conclude that ... That's it. That's basically your narrative article. It needs to be written like that, otherwise nobody can follow. So, and then the second point is write simple language. Okay? I always know when there is some French person who has written an article, because the sentence never comes to an end. I cannot follow this. It's impossible. I can't. Or it takes me very long. So here I have some examples of language that I don't like. A majority of, as a consequence of, ... The authors found that, ... Inclusion to the present study was decided by means of, ... Okay. This is what? To me, this is just pompous. I don't like it. Don't be pompous. Be simple. As a majority of, that is the same as most. As a consequence of, because, a number of, many, in close proximity to, near. Despite the fact that, although, prior to, before, the authors found that, we found, all the cases that were included in the present study, all children in our study, inclusion to the present study was decided by means of, we included children who. Okay? Right, simple, because we're all simple human beings and we don't need pomposity. The icing should be in the results and not in the language, really. Be precise when you write. What does this mean? What does this word mean? Case. What is a case? Okay, so people say, well, we found that in 5 cases it was so and so, and in 10 cases, what's a case? Is it a patient? Is it a patient? Or could it be that, you know, we looked at renal vesicoureteric reflux, and then a case could be 1 unit, right, rather than 2 units. It could also be finding, and in some instances, people mean imaging studies. So we had 5 patients, each had 2 studies. In 3 cases, we found X. 3 cases. In 3 children, in 3 studies. I don't know. Because I'm not a mind reader. I don't know. So one has to be precise. Case doesn't work. It's too imprecise. It means many different things. The value of, this is my favorite. Goodness me. The value. How many times have you read scientific articles in radiology saying the authors elected to conduct this study to look at the value of MRI in Wilms tumor? The value of, what does that mean? And value, what do you mean? Do you mean the accuracy of diagnosis? Do you mean the dose reduction you can achieve by doing MR instead of CT? Is that the value you're looking at? Are you looking at the reduction in cost benefit? Is that your value? I don't know. Is it monetary value? Or did you look at the improved patient care, the improved outcome of the patients, the increased survival? I don't know what you mean, the value of. Okay, so it needs to be absolutely crystal clear. So you have to think about these words very carefully. Because if you choose something that's very generic, the editor has seen it before and goes a little bit sour. That's it. How much time have I got left?
Around 10 minutes.
10 minutes? Well, that's luxury. What's worth writing about then, guys? So I've just set up, you may have seen this before. Okay, so for me, it's always really great to know what I'm writing about before I start writing, that sort of thing. Quite a good prerequisite, isn't it? So, for example, now let's go back and think about the value of again, okay? So people say, I'm going to write about the value of MR in Wilms tumor. So I can then ask the question based on this. Are you saying that you want to show that it's possible to get pictures of a renal tumor? Is that what you're trying to show? Yeah? And that's very often the case. And sometimes it's great. You know, if you have a new sequence or a new quantitative technique or something like that, it's great to demonstrate for people that you can actually get pictures. I mean, it's superb. I don't mind. But just say that. You're just going to show that it's feasible to do this imaging. I'm happy. Value. So value could also be, for example, that you are able to repeat your measurement, yeah, or repeat the imaging, that you always get the same. This is fundamental, yeah, because say if you look at accuracy, diagnostic accuracy, before you have proved that it's possible to repeat your measurements, that's sort of a bit of a waste of time. Anyway, To look at repeatability, I think we should do much more often. These articles are a little boring. I know they are a little boring, but they are just so important, because if you can't repeat what you are doing, that's pointless going ahead, isn't it? It's just a waste of time. You can just stop. It's very good. You know what? We should publish more negative results. Yeah, I want some of you to go home and to your hospital and you scan 100 patients with hydronephrosis, 3 different observers, and then you say, you know what? It's not. We don't get the same measurement all the time. You know, should we just stop doing these silly measurements? Yeah, wouldn't that be great to do? Great thing. I'm waiting for somebody to do that. You know, I'm a great fan of repeatability studies, okay? Just be clear what you are doing. Value of, no. Feasibility, yes. Repeatability, yes. Absolutely fine. Diagnostic accuracy, absolutely fine. But you need to make sure that it's repeatable first. Impact on diagnostic thinking. How many articles have you read that addresses the issue of how does this change the way we treat the patient? 5? I don't know. In the history of radiology, I don't know. It would be really great to see more of those as well. Okay, so these are different things that you can write about, and the synonymous word for all of these would be value of. Would just be a bit more specific, because it helps the mind process as well. Okay, let me ask you to. Now I'm going to show something a bit more fun. Yeah, graphs, scatter plots. This is fun. This is great, because you know we can actually see something here. So I have a project. I'm going to look at you know how to. I'm going to look at ADC. I have a thought. I would write an article about ADC, and I want to write an article about tumor volume for an accuracy study, say in staging or looking at outcome or something, or predicting outcome in Wilms tumor, say. Okay, I have these 2 scatter plots because I've done a little pilot study, and I'm sort of just plotting around, just looking at data. It's always good to see sort of how it relates to other data before you start. Okay, so I have to make a decision. I can either do a study on ADC or I can do a study on tumor volume. And I've looked at both in relation to tumor diameter and got these 2 scatter plots. What do you think? What would you jump on? What is sort of guaranteed to give you interesting results if you have this preliminary data? Am I a bit mean now? Come on. What would you jump on? What would you say? Oh yes, that's clear. That's what we have to do. Okay, so let's just ask the question. If tumor volume has a perfect relation to tumor diameter, then it's pointless, isn't it? It's pointless because it's just reproducing something we already have. So a good correlation usually means that you can just forget about it. You know, it's not going to be interesting because you already have it, right? But if you have something like ADC that doesn't correlate at all with tumor diameter, then I'm getting interested because I have something new. I have something that's not purely a reproduction of what we already know. See? Yeah, it's new. So now I can go in and I can say that what tumor ADC is not related to tumor diameter, maybe it's related to something else, something interesting. Right, see? So this is, I strongly suggest that you think about this, both when you plan studies and also when you read articles, because many authors of articles love to show beautiful correlations. And then you have to ask the question, well, if it correlates that well, what's the point? Right? So be critical. Done. 2 left. Result presentation. Very short. You know what? I'm going to skip that because I think that's less interesting and I don't have that much time. But I'm going to, there's one little point I want to make, because many people, when they write articles on accuracy, they put the sensitivity of the test was so, and the specificity was so, and the predictive value, the positive predictive, the negative. Okay, this I don't want to see, and I will explain to you why. Okay. So I have a test here, and I know it has a sensitivity of, what does it say, 90%, and a specificity of 75%, okay? Are you with me? So I have a group of patients, and I know the truth. Half of them are sick, 50%, and half of them are healthy, 50%. So the prevalence, or the pre-test likelihood is 50%, okay? So if you took any random patient in this sample, there would be a 50% chance they were sick. So I do my test to try and improve on this. And this is what I get, yeah? So you remember what I said. Sensitivity is 90%, and that means that of the sick, I managed to detect. The ones that are positive are inside this dotted rectangle. Are you with me? Yeah. So I pick up 90% of the red ones. So I managed to detect 90% of the sick, so hence sensitivity 90%. And of those who are not sick, I can say 75% of those are not sick. They're not positive in the test. Clear? Yeah. Okay. So let's look at those who had a positive test. So what you can see is that of all those who had a positive test, 78% were sick. And that means that the positive predictive value of my test is 78%. So far, so good. Am I a bit fast? Is it okay? All right. Okay. Now I'm doing exactly the same study again, but in a different hospital. There we go. Okay. In this other hospital, there are not so many patients with this disease. Okay. Only 10% of all the patients are actually sick. I'll do my test again. You see, all those inside the rectangle have a positive test. We know that the test has a sensitivity of 90%. That means that of all those who are sick, or the red ones, I pick up 90%. Yeah? Of all those who are not sick, I managed to say that 75% of those are not sick, specificity 75%. Same. Because sensitivity and specificity, inherent characteristics of the test. It always works. Let's look at those with a positive test. See? And now almost half of them are, or less than half of them are actually sick. And that means that the positive predictive value of the test is now, I'm very sorry, slides living their own life. I need to make this point. That means that the positive predictive value has changed from 80% to 40% just by doing the study in a different hospital. And for that reason, I'm telling authors, I don't want to see positive predictive value because it's utter rubbish. It only tells me something about the pre-test likelihood. If it's high, I know there was a high pre-test likelihood. If it's low, I know there was a low pre-test likelihood. Okay? But it doesn't say anything about the test itself. And it's the test I'm interested in. It's the imaging, it's not the prevalence. Okay? So predictive values, no thanks very much. Right. Last, is it marginally done? Okay. You know what? I think I will just stop there because I've told you quite a few things. And just to repeat the most important ones, choose the rubric that will guarantee or is likely to guarantee publication, because this was the aim, to guarantee publication. So if you don't have an original study, just do a good pictorial essay aimed at your senior registrar, residents, or do a letter to the editor. Great. Structure depends. If you're doing an original article, look at start, so you make sure that you have all the points covered. But most importantly, it has to be structured very simply. And also the writing has to be very simple and definitely not pompous. If you do an original article, make sure you do something that's actually interesting to look at, and not something that simply replicates what we can already do with another measurement. So don't look at tumor volume if you already know that tumor diameter is of some value for some purpose. Result presentation Very important to not include the positive predictive value or negative predictive value. And stats 101, that will be next time. Thank you.